system was running for quite a while, and maybe multiple devices had been connected, and uh, things had been connected. Like it had been connected from via different methods, but now it's wireless, and I've connected it through the Oculus Air link that I was showing to you right now. And now if I, so this is the demo scene, and now if I go to play mode, so now I'm able to play inside the screen. So as you can see, this is the demo mode uh, uh, that is there. So with the controllers, so this is how the controller, the demo controller is showing up. And obviously you can use whatever model, whatever things that you want to use. Like this is the most primitive version of how this can be set up. And we look into how, like what goes into setting this up. And like it's just takes 5 minutes to set up these things in VR. So in essence, whatever you have learned till now by creating things for the desktop or AR, so those are more important things, because setting up VR, like at least the camera part is like very straightforward. You just put in a camera, and then interactions are like people are still figuring out what is the best way of interacting in VR, what is like how the user experience or how the user interface should be. So UI UX for VR is a completely big research area in its own separately. So going back to this, so there are some interactions here. So when so there's a joystick on this here. So when I press the joystick, it converts to a different kind of array, and basically it's for teleportation. So if I point it towards a place where I can move in this environment, it turns green. If it turns to a place pointed to a place where I can't move, it turns red. So this is a place that I can't move to, and then this is a place that I can move to. And similarly, so it also provides something called as a snap turn provider, which we'll look into how to set those things up. So when I do this, as you can see, I'm turning the angles quite swiftly, right? So I can change the angles while I'm sitting here. But when I want to be more immersed, then I don't want to use this kind of a setup. I'll basically look around on my own. And then let's go here and see. So basically these are some different objects that we can grab. So when I point to an object, it's basically the ray that you see coming out of this turns to blue. And there's this grab controller. When I press on this, it basically grabs this object. And these are three different ways of how the object is grabbed. So kinetic movement, instantaneous movement, and velocity track. So velocity track is something that basically goes along with how you have tracked. Sorry. So how your like it tracks, it goes along with your movement, and then kinematic follows uh, like basic physics, and instantaneous also has some meaning to it. I don't remember exactly, but this is generally how all the different things are there. And then you can play around with these objects, throw them around, all the things, right? And this is one basic thing. Uh, and then when I go to the other part, this is where some in UI interactions have been shown. So there's a slider, and this is how you can change the slider in VR, and then buttons are there. So this is just a basic setup of UI as well. So UI also works similar to how it works in uh, like a desktop version, but a bit of things are different. Like you have to have a different set of strategy for how you place UI in VR. And then coming on to the scene that we were setting up. So let me add a XR origin now here. And this, no, first let's add without the VR part. Let's just add a single simple XR origin. So this does not have the, as you can see, this does not have the controllers. So now if I go into VR, so as you can see, I am able to uh, see the environment. but my controllers won't show up in the environment, right? So this is the environment that we set up, and this is where I am. So now let's look into getting our controllers in the environment. So the very basic again step is that, and once you add the XR origin, this thing XR interaction manager gets added on its own. So let's add the XR origin VR system and zero it out. And then tracking origin mode can be set to floor. So the device, when we set up, it kind of asks us where the floor is. So it calibrates your height according to where the floor is, and when you move, it like basically knows where the floor is for for you. So that kind of gives a real feeling, as if you're moving, like when you physically place your foot on the floor, that matches to where your foot is in the VR world as well. So this is like doing this, and then just going here, we'll have to, I think, add the presets. So one thing to check is that the camera, VR camera is the main camera. And then these things, as you can see, these are empty. So these are all the input actions that we'll be using. So this is the left-hand controller, and we can use this to basically add the presets. So this is a preset manager. So we need to set the left controller. And similarly for right hand, we'll set the right hand controller. And there are other settings here. So there's XR controller, which is basically controlling all the things like different actions, different input, all the buttons and everything. Then there's ray interactor, which is basically throwing out that array that we saw. And by default, it's throwing out a red array when it interacts with something that is interactable, it turns to white, all the things that are by default. And then when we go to VR, let's see, we'll be able to see the controllers as well, and some kind of array would be coming out of it. But as you can see, it's not interacting with anything, and I don't have a controller as such here, right? Because I haven't added a model to the controller, but I can see that array is coming out exactly where my controller is. So the next step would be to add some kind of a model to this controller. And that can be the model that was provided in the sample assets. So how it is done is basically, I'll add things to the right hand only because I'm using only one controller. So I'll add the things there only. So this is where we add the model prefab. So if I go to the starter assets, prefabs, uh, models, yeah, so this is the one left and this is the right one. So we can use this so this is one way that we can use this one, but we have already seen this. So what I wanted to show is that we can create whatever we want. We can have our own things as well. So let me create a folder for prefabs. And what I'll do is I'll create a cube and let's call it and model primitive. Let's change the shape a bit. So 0, 0. So might be a little bit too big still, but let me convert this to a prefab and we can change it later. Let's delete this. When we go to right hand, we can just add this here. And now this will show up as our control. So when I go to VR now, so as you can see, it is quite big. The scaling is quite different as we would consider. So we can bring it down, scale it down a lot, or we can even convert it to something else. So let's say I don't want to use a cube. Let me convert it to a sphere and make it 0 0.05, 0 0.05, 0.05. So like a really small cube. So this is how now the controller is showing up. It became too small now. So, but yeah, so this is generally how you can set up any kind of model. So if you find a 3D model online for Quest also provides their own controllers model. So you can use those, or you can create your own models. You can create hands, you can create alien hands, whatever. So depend like imagination depends on your imagination. So once this basic uh, like the controllers and setup is done, now let's look into how we can actually move around in this environment, right? So we need to set up something called as a locomotion system. So for that, there are different ways of doing it. But what I would do is basically create a uh, empty child inside the XR origin, and let's call it locomotion system. And on this locomotion system is where we'll add the locomotion system. And what this needs is the access to the XR origin. And now there are different locomotion systems that like we can add. So the very first thing that we can add is the continuous move provider. And in this, as you can see, there are action based and device based. So action based would be like if you add it, it will be able to like it will bind the actions and not be bind to a specific device. So similar to why we were using the new input package. So this is the same concept. So we'll be using the action based. So continuous move provider is a bit uh, like straightforward, like how you move in a normal desktop based environment is how continuous move provider will be here. So once you add this, there's option to add speed, say enable strafe, enable fly, use gravity, all these things. And all this needs is a forward source, which will be your main camera. Sorry, for the forward source will be main camera. It also needs the locomotion system. So locomotion system would be this only. And then it also wants to know what like what should I be pressing on my controller to actually be making this kind of input to actually move, right? So if I use a reference, then I have something already created. Uh, locomotion move, I think. Yeah. So this should be it. So XRI is XR interaction, right hand locomotion move. So if I go here, I can see inside this. So right hand interaction and right hand locomotion and move is here. So move is basically the primary 2D axis. So what this means for Oculus is this joystick basically. So there's a joystick here and this is what it means for Oculus. So let's see if this actually works. So what this will give us is a continuous movement uh, inside VR. So as you can see, I'm moving, but you will see it as a bit weird because there are no objects in the scene. But I am like, let me add a few objects so that the representation is actually there. So I'll add a few cubes here and there. And let me change the colors as well so that it's more easier to see. So one can be red and then can have blue, yellow, So also make the floor black. Now let's see. So as you can see now I'm moving. And what basically adding the this thing had done. So when I added the locomotion system and when I made the forward source to main camera, what this basically is doing for me is when I move to this side and I'm still using the joystick forward, I'm able to move in the direction that the camera is pointing. Okay. So my forward source is the camera, which basically this is what it means. And then similar to continuous move is basically just providing me access to front, back, left, and right. So this is similar to WASD keys. But now I also need mouse movement, right? I also need to be able to turn around using my mouse itself or my uh, keyboard itself. So that for that we have continuous turn provider. And again, similar concept here, we need the locomotion system. And for the right hand, we use this and we have a turn provider already. We'll also talk about snap turn shortly. So turn. And then when I go here, then I'm also able to turn in my environment. So when we talk about motion sickness, this is generally what causes motion sickness in VR because uh, your body is still, so your brain thinks that you're not moving, but your eyes are feeling that you're moving. Even if like using this kind of a setup where basically your body is continuously moving, right? Like each frame, your body or your eyes are able to understand that some kind of movement is happening. But your brain is thinking that movement is not happening because in actual physical world, you are sitting still. So this causes a problem of nausea generally. So for people who have low tolerance, it immediately they'll throw up in this kind of a setting. uh, if you are standing up, you'll start falling down. So it causes a lot of problems. So to kind of counter that, instead of using continuous move providers and continuous turns, we have teleportation and snap turns. So we'll look into how to set those up as well. So let me turn the continuous move provider off and sorry, I'll need to have continuous move provider on for right now, but we'll look into teleportation after this. First, let's look into the snap turn. So what snap turn will do is like right now is moving continuously, turning continuously. Snap will basically fix an angle, and every time I press the joystick to right or left, it will turn that much angle only. So like the angle right now is 45 degree, and I just need the access to my loco system. Then provide a reference to the snap turn. And that's it. That's all the setup that is required. So now when I go here, and now if I press on this, as you can see, the debounce time is 0.5. So after every 0.5 second, I'm able to turn itself. So right now I'm able to snap 45 degrees every time I do this or do left, right? So if I was only doing right, so I'll also show left. So when I turn left also, this works. So this is in like general uh, about the basic teleportation system. So now what if I want to move around in the environment as well, right? Like teleport in the environment. So for that, I have a teleportation setup as well. So let's try that out. So here I'll need a teleportation provider. Like I don't want to define a teleportation. So teleportation provider will just ask, like check where the ray is pointing. And if that where the ray is pointing is an area where I can teleport to or not. So for now, let us try. I'll have to check if this is possible. Like if I'll make my plane a teleportation area, and do I need to add anything here? I need to add a teleportation provider. So I'll add this. And other than that, I think it's more or less fine. Nothing is needed. So let's see if this works. So basically what I did is the entire plane right now can act as a teleportation system, like would work for teleportation. It will allow teleportation anywhere in the entire plane. So for teleportation, the grip of the, so there's a grip button as well, which is basically being used for teleportation. So if I click here, I'm able to teleport. So similarly, I can make these things also into teleportation anchors. So for the plane, I use something called as a teleportation area. But for, let's say, for this cube specifically, I'll use this cube, I'll use teleportation anchor. So anchor is basically a smaller place, like it will basically not be a bigger area. So it will anchor to the center of the anchor. So like it will take me to the center of that position. And I can also have a like what something point up when I point there. Like if you remember when I was using this, there's a this thing was coming up if you remember, right? So let's try this one out and let's see if we are able to use this. So this thing we were setting up. Yeah, so this was set up as the teleportation anchor, and then this has a custom reticle. So I'll add a custom reticle, this one. And anything else required here? Teleportation configuration. So this requires a teleport location locomotion system. Sorry, teleportation provider, which is on our locomotion system only. And let me try it out the plane as well to basically have a custom reticle. So the plane would have this custom reticle. Let's see now how this looks. So as you can see now, wherever I point, I'm able to like see the custom reticle. And on this, there's a different kind of custom reticle will show up. And if I go here, as you can see, I came on the center of the object. So yeah, so this is like the general concept of teleportation. Uh, I think that covers a lot of things. Next, we'll look into grabbing objects in VR and then trying to throw them away. So for that, what I'll do is I'll set up sort of table near us. So let me make a clone of this, bring it somewhere in the middle. So let's set up a few objects like we did. Like let's just take the objects from here itself and set it up here on top of this. So these were the objects that were there in the other scene, and I'll color them for a bit of. So for these, what we need to do now is basically convert them to grabbable objects. Uh, and basically for that, we need XR grab interactable, I think. Yeah. And all this needs is the transform. Uh, so this is the movement type that we were setting up there. So instantaneous, kinematic, or velocity tracking. Let's change it to kinematic for now and I can't remember if I did anything else. I think we don't need to set anything else as of now. Let me try it out once. But as of I remember, the object I think fell off. Yes. There's something I'm missing. I might have to define it somewhere. So I forgot how to do that. Statics are based on. I just need to define in grabbable. So yeah, so this is something that I'll have to check. I forgot right now, but yeah, so we saw it in action, like we can explore it there, the things that have been done, and then maybe try to implement it here. So starter assets, this demo scene, and basically what it had was the XR interaction, interactable only, grab interactable, and I don't see any other difference here. Origin. I think this is what we need to add grab provider. So I will try it out once, but other than that, there also might be that we need to add this interaction manager as well, which I have not added. Interaction manager is added, sorry, the input action manager, which I have not added. So let me go here, say, origin input action manager is there. So here we can try the grab provider 200 Excel. So let us see if this works. Otherwise, we'll move on from this. Oops. Yeah, I am missing a step. Pretty basic thing, I suppose. But yeah, so this is general of how things are, how you can set up things in VR, how different things are. And if you have any questions regarding this, then I can have those questions. And I will just a second to how did I miss that? What was I supposed to add? Yeah, not sure what I'm missing. So anyway, so yeah, so this was general setup about VR and how things are done in VR. Basically, there's a lot more to this after, like, let's say you're creating a shooter game, then basically instead of using a controller, you can have a gun instead of a controller directly in your hands. And then all you will need to do is basically map the input actions from here to the input actions that you've already created for the revolver or the gun. So like if you want, you can convert the project that we created, the zombie shooter game, to a VR zombie shooter game. So I mean, basically, you'll be able to do that in an immersive environment. So this was one part, and then moving on to the other part is, so this is all I discuss about VR, and then we also wanted to discuss what other things Unity provides. So just a sec. So I'll be talking about two things. RL research, which is basically reinforcement learning research, and how Unity and other game engines. So this is like the setup for RL. So there's a tool called as ML Agents Toolkit, which is how Unity is supporting reinforcement learning research. So let me open that web page as well. So this is the ML Agents Toolkit, and it has a lot of like, these are some basic environments that we can look into as well. Just let me open it. So what reinforcement learning means is that, like right now, when we created the game of the shooter, like the zombies, we wrote very basic AI, right? We wrote an artificial intelligence that was basically looking at the distance of itself from the player. And if the distance was less than, greater than something, then it is just following the player. If it is less than something, then it is stopping and attacking the player. Now, this can be converted to a learnable behavior. What that means is that if I am able to make the uh, make an agent want to do this, like learn to do this, to like get some rewards. So like how we humans or animals learn anything is based on rewards. It can be positive rewards or negative rewards, but we learn based on rewards. So like from very beginning of our life, when we do something good, we are rewarded positively. When we do something bad, we are rewarded negatively, something like that. So like let's say how do you learn to not keep your hands on a burning stove? So if you like do it once, you will know that this is not something to touch when it is hot, right? And how do you keep that in memory? So that is something known as exploration. So first you're exploring the world, and then you make a set of rules for yourself: not touch hot pan, uh, or any other kind of rule, eat food between 8 10 p.m., whatever basically you are able to learn, you're creating that set of rules for you. Similarly, based on the same concept, we also learn as human, animals also learn, and similarly machines can also be learned on the trained to learn on the same concepts. So what reinforcement learning does is basically creates an environment for a machine to learn. So let's say, like right now, what you see examples here are basically similar to basic games, but what is happening here can be converted to very big examples. So big examples like something, let's say I train a drone in VR or in a virtual environment to do flying on its own. So control its own flying. And based on what it has learned in the VR or a virtual environment, it's able to do that in the real environment as well. Like maybe not 100% perfectly, but it has an initial start. So it has a starting point and it's not blank when it's going out in the environment. So that is where this is providing a lot good. So this is a examples package again from ML agents. I've downloaded it recently, and basically it has a lot of different examples. So like this is the most basic example. The task here is that the blue object that you see, it will spawn near a small dot and it has to go towards a big dot. But I can code that, but I've not coded it. The way that it is structured, it's basically using this neural network model. So it is a kind of a brain that the this agent is using. And in this behavior type, I'll change it to inference. Inference means that it's not learning or it's not heuristic. Heuristic would mean that I am controlling it. Inference would mean that this brain is controlling it. And by default, it basically tries to go to training. So for training, this can be connected to a Python-based system, and uh, like that happens. So right now, what it has learned, this agent has learned, is that it starts in the middle and it has to go to the bigger of the two. So this is something that it learned. It's the most basic thing that you can do with that. Then let's maybe look at a bigger concept. So this is a food collector. Here again, let me see. There is the agent. So there are different, like, so generally when agents are trained, they're not trained one at a time. So this is one again beneficial way of why we use virtual environments. We can train more than one agent at the same time, and all this combination can go into a single brain, single storage memory, basically. So let me just see which one is in our view. I think the very top one is in our view. And in this agent, let me convert all the agents actually to have the brain working. So inference, right? And let's see. So this is a paradigm where basically it has to collect food of the same color. Okay. So as you can see here, or something else, I don't remember the exact objective of this simulation, but there are 5 agents in the environment. There's some kind of food that is available on the ground, and they have to collect that food for sustenance. So there are rules defined, and then basically you allow the agent to first explore. So there are thousands of and millions of steps of training involved in this kind of a simulation, and then eventually the agent learns to do something. So let's try one more, the soccer one. So soccer tools, striker versus bullies. Let's try this one first. So maybe we can have one as a inference. Blue striker, purple striker, blue striker, purple striker. So we can have 3 as inference, and maybe I can also control one. Let's see. One can be heuristic. So this is also like a way where you can enhance your games as well, like by using AI-based agents instead of state-based agents. So as you can see, I am not able to match their speed. I am just looking around. So the player that you see randomly moving around, that's me. This one, which is who's not able to figure out what to do. So while the rest of them are basically playing football. So this is an example of how you can basically use reinforcement learning. And the way that it has been set up is something like you first install the Unity package for ML Agents Toolkit. So it's very straightforward, and the guides and everything are pretty easy to understand. So you first install the ML Agents Toolkit for Unity, then you install the ML Agents Toolkit for uh, Python, and then basically when you create the environments here, you have a YAML file or a configuration file basically that defines what kind of training has to be done. So like RL is a big concept, and specifically here, deep reinforcement learning is being used. So it's a very new big concept, but this is a very interesting area that if you are looking to explore research in AI, this is a very up and coming area. A lot of very few people, this is a very niche area as well. So very few people are doing this right now. So yeah, so this is one area. And then the next area is computer vision, where synthetic environments and virtual environments are impacting a lot, right? So what does Unity provide for us in that is sorry, basically it has this like Unity has focused a lot recently towards computer vision. They also provide synthetic data as a service now. So basically, if you want, you can like if you have a problem statement, or if you have some uh, mission statement, basically that you want to classify text inside a room, that text should be written in Hindi or Bengali or whatever, and you can basically create this kind of data using virtual environments. And results have shown that, like initially what people used to do, like they had, let's say, limited data set from the real environment. Let's say I have only 1,000 images from a real environment. For me, what I would do as a computer vision researcher is I would use some basic data augmentation techniques, and I'll convert this 1,000 images by like changing rotation, shape, things like that, to maybe 5,000 images. But by using virtual environments, I can create completely new uh, 10,000 images at an instance. All I need to do is set up a virtual environment, add a camera, tell my camera how to capture the things, animate that camera, like, and that also Unity has provided us with a Unity perception package. So this is a perception package, which basically gives us some tools on how like computer vision data sets should be captured. So like in general, this is something called as scene segmentation, what you see on the right side of this image. And then like when you select specific objects, that is something called as object detection. So how do you label the data that is coming for these kind of things, right? So this is available here. Like it's open source, and it's you're free to contribute and you're free to use. So if you're like if you have done maybe some basic work as well in the computer vision, if you have done object detection, face recognition, things like that. So this area of exploration would be a very good area of exploration for you. So like trying to use or trying to generate synthetic data from virtual environment, and then mixing this data with real world environment, and then trying out if that works, or maybe just using like training on completely virtual data and then testing out on real data how that works. So there are different, like a complete different group of researchers doing these kind of works as well. So this is my final note as of now. I don't have anything to show for this right now. We have a project that is ongoing on this as well, where we were basically trying to create synthetic text on in wild. So text in wild is a big problem, which basically means that wherever text is written, however it is written, whatever language it is written, a machine is able to identify and translate and give it to you in a readable format. So for that, we were basically trying to create environments where town or city-based environments where text is written randomly at places, and then we are able to capture that data set and create a data set out of it. But like right now, it's not sure where that is going, but this is a general concept of what we were looking to do. So this is something that you guys can also explore. So these are the last two things that I wanted to say. And then that's it from my side. And then you are free to reach out to me anytime you want. You have my number, you have my email. I'm also available on LinkedIn, Twitter, this TopMate. So TopMate.io is also a platform where you can schedule meetings with me if you want specifically. Uh, and that's it. That's all from my side. If you have any questions, you can ask me now.
So mine would be on the submission of the project. So would we just
Yeah.
submit a WebGL version of it or the entire Git repository?
I've asked Aditi to create a form and she'll share it. I'll share it with you guys in a few days. So it has options to submit four things. One would be a WebGL, like a playable version. If that playable version is like if you have implemented in WebGL, then link to that WebGL. If it is not a WebGL version, if it's a desktop, it's an NAR app, then upload it to Drive and link to that Drive. And then the second thing would be the GitHub repo, like public GitHub repo of the code of everything. Third thing would be a showreel or a video kind of thing for like displaying what you have created. And the last would be, what was the last thing? There were four things. What three things were? Game, code, video, and yeah, a design document. So like the document that I've shared with you. So a design document as well. So those four things would be required to submit.
So is it necessary for us to do all of them or one is good enough?
It's like if you do one, you're doing all anyway, right? So if you've created the code, you are anyway like going to build it. So the code is going to be on GitHub. The build is going to be either on a desktop or on a mobile or on a WebGL based platform. So you just have to share that link. And then a design document is a separate work. But other than that, the three things code, uh, link to the actual game, and link to a video showcasing the game. These are like, I don't think there's much effort to that. Design document is something that you should learn how to implement, how to create. That is why it's a separate task.
Got it, sir. Thank you, sir.
Okay. So anyone else, any doubts related to project or anything else? Okay, so if you have any further questions, you can ask in the group. And for now, I guess this is where we'll end. Thank you, everyone, and special thanks to the coordinators, Akshat, and both the Aditys for constantly supporting us. Thank you so much.
Thank you. Thank you for your time, sir.